All right, good morning, everyone. Welcome to Research Methods 101. I am absolutely thrilled to have you all here today. Honestly, I consider this to be the most foundational, eye-opening explainer of your entire academic career. Seriously, today we're taking our very first steps into the actual mechanics of how we know what we know about society, about economics, science, human behavior, the whole shebang. So, grab your notebooks, get comfortable, and let's jump right in.
So, right off the bat, I want to throw kind of an impossible problem your way. How in the world do we study society without actually asking everyone in it? Think about it for a second. If you wanted to know what all college students think about remote learning, you can't possibly interview millions of them, right? You don't have the time, you certainly don't have the budget, and you definitely don't have the sanity for that. So, how do researchers make these broad, incredibly accurate claims about massive groups of people? Well, today we're going to open up the exact toolkit they use to solve that very problem.
Here's a quick look at our course syllabus for today's explainer. 1. Welcome to the universe. 2. Probability, or the random rule. 3. Non-probability, or deliberate choices. And finally, 4. Your research journey ahead.
Kicking things off with Section 1, Welcome to the Universe, where we'll get the absolute basics of sampling down.
So, sampling, it's basically this elegant mathematical solution to that impossible problem we just talked about. Simply put, it's a technique where only a selected fraction of the total population is studied. But here's the absolutely crucial part, okay? The entire goal is to make valid inferences without bias. We don't just pick people randomly because we're lazy. We do it strategically so that our small group accurately reflects the massive group we actually care about. To really wrap your head around this, there are two key terms you absolutely need to know: universe and sample. Think of the universe as the total population being studied. It's like, imagine a giant bubbling pot of soup in the campus dining hall. The sample is the representative items chosen from it. It's that one spoonful of soup you taste to decide if the whole pot needs more salt. You don't need to chug the entire 50-gallon vat to know what it tastes like, right? As long as the soup is well stirred, that single spoonful, your sample, tells you everything you need to know about the entire universe. Now, this brings us to what I call the great divide in our sampling taxonomy. If you're taking notes, definitely map these two main branches out. On one side, we have probability sampling. This is where every single item in the universe has a known, equal chance of being selected. On the completely opposite side, we've got non-probability sampling. This is where the investigator uses their own deliberate discretion to pick the sample. So no equal chance for everyone. Basically, the soup is stirred very differently depending on which side of this divide you stand on.
Okay, moving into Section 2, probability. The random rule, or basically ensuring an equal chance for everyone. Let's dive into this. Let's start with the most basic form of this: simple random sampling. This literally puts everyone on a completely equal playing field. It's often called the chance or lottery method. Imagine putting the names of everyone in your dorm building into a giant hat and just pulling out 5 names. Everyone has the exact same chance of being picked. Now, in professional research, instead of a physical hat, we usually use computer-generated random numbers, but the core principle is exactly the same. And this works brilliantly for homogeneous groups where everyone in the group is relatively similar to begin with.
But, what if you want to be just a little more systematic? Well, predictably enough, that gives us systematic sampling. Here's a really easy step-by-step procedure that is absolutely perfect to jot down for your midterm study guides. Step 1. Arrange your population in a specific order, let's say alphabetically. Step 2. Use a random number just to pick your starting point. Let's go with person number 4. Step 3. Select at a fixed interval from then on out. So maybe you survey every 10th person after that. You survey person 4, then 14, then 24, and so on. It's highly structured, but because that very first starting number was totally random, it beautifully maintains that equal chance rule.
Next up, we've got stratified sampling. And let's just pause and decode that fancy piece of academic jargon. Strata. It literally just means layers or subgroups. We use this when our population is not homogeneous. Let's say our campus is 60% undergrads and 40% grad students. If we just pull names out of a hat, by pure chance, we might accidentally pick all grad students. To fix that, we divide the population into strata: 1 bucket of undergrads, 1 bucket of grad students. Then we randomly sample from within those specific buckets to guarantee our final sample perfectly reflects that 60-40 split.
Now, what if the area you're trying to study is just massive? Imagine trying to survey households across an entire country using random names from a hat. You would literally spend your entire research budget just buying plane tickets to fly from one random house to the next. And that is exactly where cluster and area sampling come to the rescue. You divide the population into wide geographical areas, randomly select a few of those specific areas, and then, here's the real kicker, you study all the items within those chosen clusters. It's incredibly efficient.
And this actually leads us perfectly right into multi-stage sampling, which is basically just cluster sampling taken to the absolute next level. Look at how we drilled down from giant geographic areas all the way down to individual households. Stage 1, randomly select whole states. Stage 2, within those states, you randomly select districts. Stage 3, select towns. And finally, Stage 4, you select the actual families to interview. By moving in these stages, a researcher can manage a massive, large-scale survey without completely losing their mind.
All right, shifting gears to Section 3, non-probability, deliberate choices. This is when researchers step away from the random number generators and really just use their own judgment.
Consider this your ultimate side-by-side study snapshot for non-probability methods. We're looking at convenience, judgment, and quota sampling. Now, in all three of these, the researcher is making a deliberate, conscious choice about who gets included. Which means, and this is key, some people in the universe have zero chance of being picked. Let's break down exactly how each one works.
First up is convenience sampling, and honestly, this is exactly what it sounds like. Our source material gives a super practical example. Let's say an investigator wants to survey people who buy petrol. They might just walk over to a couple of nearby petrol stations that are within easy reach and interview the customers right there on the spot. They aren't randomizing a list of all the petrol stations in the entire country. They are choosing purely based on ease of access for themselves. Quick, easy, convenient.
Then we've got judgment sampling. Here, the researcher's personal expertise is the guiding force. The investigator deliberately selects items that they truly believe constitute a representative sample. For example, if you're an expert studying a really rare economic trend, you might use your deep, specialized knowledge of the field to handpick 5 specific companies that you know best illustrate the problem. It's incredibly useful in qualitative research, especially when you're just starting out and trying to develop your initial hypotheses.
The third method here is quota sampling, and this one is pretty fascinating because it blends a highly structured approach with complete personal discretion. Similar to stratified sampling, you divide the population into groups and set a quota, like, okay, I need to interview exactly 50 science majors and 50 arts majors. But unlike stratified sampling, you don't pick those students randomly. The interviewer on the ground uses their own judgment to find them. They might literally just stand outside the science building and grab the first 50 people they see. It fills the strict quota, but relies entirely on the interviewer's discretion.
Finally, Section 4, your research journey ahead, putting all these methods into practice.
Okay, take a deep breath. We just covered a ton of heavy academic jargon today, but you made it. Let's just do a really quick recap of this taxonomy journey so it truly sticks in your mind. Remember, probability means an equal known chance for everyone. That includes your simple lottery, your systematic intervals, your stratified layers, and your cluster and multi-stage geographical drills. On the flip side, non-probability means deliberate investigator discretion. That's your convenience, your expert judgment, and your interviewer quotas.
Before we wrap up, I really want to leave you with this foundational quote straight from our source material. The basic assumption behind sampling is that the chosen sample items truly represent the characteristics of the overall population. This right here, this is why we care. This is the entire point of everything we've talked about today. Making valid inferences without bias is the ultimate goal of any researcher. Because listen, if your sample doesn't actually represent your universe, your conclusions are going to be completely wrong no matter how perfect your math is.
So I'm going to end today's explainer with a little challenge for you to take out of the classroom. If you had to survey your own dorm building tonight about, extending cafeteria hours, which sampling method would you use and why? Would you pull room numbers from a hat? Would you divide everyone by floors? Or would you just ask the people you bump into in the hallway out of pure convenience? Think about how the method you choose completely changes the reliability of the answers you're going to get. Welcome to the fascinating universe of research methodology class. I'll see you in the next explainer.